Hey guys, I'm going to take a quick minute or two here to go over an example very similar to your concept 3 illustration 4 example of your vector project. So this concept basically is just right triangle trig, angles of elevation, and rate of descent. And you need to know a few things. Number one, you need to know how far out your plane starts its descent. So for the sake of this example, I'm going to say it's 150 miles from the airport. Next, you need to know the ground speed of the plane. Now, you will calculate this in your project. So this will be concept 2, illustration 2. But for the sake of time, I'll just state here it's 475 miles per hour. You also need to know the elevation of the plane. And for this example, I'll say it's 55,000 feet. So the first thing we're going to do is create an accurate labeled illustration. So a diagram, but this time from the horizon, representing the airplane, the airport, and the angle of descent. All right, so let's make a quick sketch here. So we've got our plane, and we've got our airport. And what's happening is the plane is descending to the airport. Well, we said it's right triangle trig, so we'll just finish the sides here of this right triangle. And what do we know? Well, we know the elevation is 55,000 feet, and we know it starts its descent 150 miles out. So one issue here we have mismatch units. So I know I need to use both of those. Generally, to avoid rounding issues, it's better to convert to the smaller unit, which means we'll just multiply 150 by 5,280 feet per mile. So in doing that, I got this really big number, but it's 792,000 feet. So now we'll use that number for that side of the right triangle. Okay. I need to find the angle of depression to the nearest minute. That's this angle here. Why is it that angle? Because remember, that's the same as the true angle of depression, which is that one. They're alternate interior angles, so this one works out nicely because it's in the triangle. This is simply going to be tangent. So in part A, to find that angle theta, I just need to do inverse tangent 55,000 over 792,000. Notice also it says nearest minute. So just to save a little bit of time, I'm going to put that right into my calculator and then do DMS. Just make sure you close the parenthesis before you do DMS. You can hit enter and then do DMS. It just saves one step doing it this way. I got 3 degrees, 58 minutes. This is not a heading. It's not a bearing. Don't overthink it. That is simply the angle of depression you need to take to get to the airport if you're 150 miles out and 55,000 feet up. All right, part B. This is where it gets a little bit more challenging. Part B, I need to find the feet per second of descent to the nearest foot. Now, what they're talking about there is how fast you're dropping in elevation. How many feet per second is the plane coming down in altitude? Well, we need to do a little bit more here. Number one, we're going to have to find this distance. How far is the plane, the direct distance from the plane to the airport? Well, that's not hard to do. It's simply Pythagorean theorem. So let's start by doing that, getting our distance d. Okay, well, the distance is going to be the square root, 55,000 squared plus 792,000 squared. Right? It's just Pythagorean theorem. So I did that and came up with 793,907.4 feet. That will be this hypotenuse right here. 793,907.4 feet. Great. So I've got that. What else do we need to do? Well, it kind of gives you a hint here. How many feet will the plane travel on its descent? So that's what we just found. We found this hypotenuse. How many feet will the plane have to descend? Well, we know that it has to descend 55,000 feet. How many seconds will it have to do this in? Well, that's where it gets a little trickier. How long do we have for the plane to travel this path? Well, that's why we need to know its ground speed. if I know the ground speed and I know this distance, I can then calculate time. Well, how do we do that? We have to remember a simple formula. Distance equals rate times time. And if we need time by itself, it's simply distance divided by rate. So if I need to figure out the time it's going to take for the plane to fly from its position, 55,000 feet up, 150 miles out, to the airport, whose distance is that, and ground speed is 475. Oh, wait a minute. 475 miles per hour. This is in feet. So first thing we need to do is convert that to feet per second, all right? So that's not too hard. We've done this before. So down below somewhere, 475 miles per hour. And let's do that conversion. Times 5,280 feet in 1 mile. Times 1 hour, 60 over 60 minutes. Times 1 minute over 60 seconds. Let's just double check. Miles cancel, hours cancel, minutes cancel. What are we left with? Feet per second. So you throw all that stuff into your calculator. I got 696.67 feet per second. So that is the ground speed of the plane in feet per second, which now matches my units up above. So I can go back to this formula. I'm going to take the total distance, divide it by my rate, which is now feet per second. Okay, let's do that. Total distance, 793,907.4 feet, divided by our new speed here, 696.67, and that's feet per second. So when you divide this out, the feet cancel, and you're just left with seconds. When I throw that into the calculator, I end up getting 1,139.6 seconds. So now, what that tells me is it takes that long for the plane to descend to the airport. So the very last thing we need to do, if we want the rate of descent, we know how long it takes to travel this. We know my elevation is 55,000 feet. So if I want to find out how many feet per second it's dropping this way, then I just divide again. Okay, so my final answer here is going to be 55,000 feet divided by 1,139.6 seconds. So that is going to give me a rate of descension. If I divide that out, round to nearest foot, 48 feet per second. Remember, that's not the speed of the plane. What that represents is how fast the plane is dropping in elevation. Every second, the plane drops 48 feet. I hope this was helpful. Good luck finishing the project, and we'll see you guys in class soon.